Alright, mathletes, here we are looking at axes of symmetries and vertexes of quadratic equations and parabolas. Okay, so axis of symmetry is a line that's going to divide our parabola into two symmetric halves. Notice our axis of symmetry is always going to be vertical. And remember, so vertical lines are always going to take the format of x equals some value depending on how far left or right it is from our axes. Okay, our vertex is always going to go through our axes of symmetry because it is the lowest turning and lowest point or the highest point of our parabola, and it's that turning point where we go from a negative gradient to a positive gradient in that parabola. So that vertex and the line of symmetry are very related. The vertex, what's nice is the x value of your vertex is always the same as your line of symmetry. Okay, so if we're given a parabola here, so notice this parabola is concave down, and I want to find my line of symmetry, notice I have my x-intercepts of being 2 and 6. What's nice is I know that my line of symmetry falls right in the middle. So I can find the midpoint between 6 and 2. Okay, so to find the midpoint's like finding the average, so I can do 6 plus 2 divided by 2. That's 8 divided by 2, which is 4. Okay, so here, and remember it's always the form of x equals the value of 4 is going to be my line of symmetry. So that's if we're given a graph and the x-intercepts. Okay, so sometimes we just want to find the axis of symmetry, okay, from our equation, and if we're given the equation in standard form, okay, our axis of symmetry is always going to be x equals negative b plus 2a. This is a very important formula to make sure you have in your notes. We'll use it a lot. Okay, so if I want to find my axis of symmetry with this example here, I again try and identify my a value is 2, my b value is 3. So by evaluating into my function, or into my equation for my line of symmetry, I have x equals negative b, so negative 3, over 2 times my a value, which is 2. So this is going to be negative 3, and 2 times 2 is 4. Always simplify this fraction whenever is possible, but in this case we can see it's there, so negative 3/4 can't be reduced, so we get x equals negative 3/4 is our line of symmetry or axis of symmetry. Okay, so when we're talking about our vertex, okay, remember our vertex is either going to be a maximum, okay, if our a value is less than 0. So that's like if a is negative. So if that value is negative, we know it's concave down, so we have a maximum point as our vertex. The other scenario is if our minimum value, so if a is positive, okay, we know it's going to be concave up, which that's going to give us a minimum point for the vertex. Since that vertex lies on the line of symmetry, we can always find that x-coordinate using the same equation we use for our line of symmetry. And to find the y-coordinate, okay, it can be found by substituting in this same value into our function into x to find that y-coordinate. So let's see how this is going to look. Okay, so first part here is I'm going to find my axis of symmetry. So I know that is x equals negative b over 2a. So again, identifying my a value here is equal to negative 1. My b value is equal to 2. So negative b is going to be negative 2 over 2 times negative 1. Simplify this, I get negative 2 over negative 2, which is equal to 1. Okay, so at x equals 1, so x equals 1 is here. I can graph it on here. I just draw it at a dotted line because it's not an actual part of my graph, but this is my axis of symmetry. Okay, so in part B, find the equation of the axis of symmetry. Oh wait, that was my part B. Okay, I found my axes of symmetry. Okay, if I want to find the axes intercepts, okay, so again, I know that my y-intercept is equal to my c value, and my c value is 3. Okay, so y is equal to 3. That is my y-intercept. Get my x-intercepts. Okay, so that's when my y is equal to 0. So I have negative x squared plus 2x minus 3. And, well, again, I have a negative a value here. So when I'm solving this quadratic, I find it much easier to deal with a positive a value if I'm going to try and factor. So I'm going to move things over to the other side. So I get x squared minus 2x plus 3 is equal to 0. If I solve this by factoring, okay, do my diamond method, I get 3 and negative 2. So I'm looking at negative 3 and a positive 1. So I get x minus 3 and x plus 1 equals 0. What makes those 0? Well, this happens when x equals 3. Here, when x equals negative 1. Okay, I'll graph these in green as my x-intercepts. So I see at x equals 3. Okay, and negative 1. Notice how my line of symmetry is right in between those points, so that helps me kind of verify that I'm doing things all right. Okay. Well, now that I know those things, I can move on to C, which says find the coordinates of the vertex. Well, the coordinates of the vertex, I have the first part for that. And that first part is the x value, which is exactly my line of symmetry here. So I know my vertex is 1. Well, in order to find out my y value, I need to substitute that into my entire equation. So I'm going to find out my y is going to be equal to negative 1 squared plus 2 times 1 plus 3. Okay, so 1 squared is 1, but I got to make it opposite, so it's negative 1 plus 2 plus 3. So the positives add to 5 minus 1 is going to be 4. So that gives me the y coordinate of my vertex. So at 1, 4, I can see my vertex is going to be right there. Okay. Now that I have all those pieces put together, I can go ahead and sketch my function. Okay. So knowing its a value is negative, so I'm concave down. I'm just going to kind of connect the dots. The maximum point is at my vertex, and I have my quadratic there. Okay, let's look at one more example here. So consider this quadratic. So notice it's in factored form. So if I want to find the axes intercepts, okay, so first I'm going to find the x-intercepts. So that's when y is equal to 0. So I get 2 times x minus 2. So it's already in factored form. That makes my life a lot easier. So I know this is going to happen at x equals 2 and x equals negative 4. That's my x-intercepts. So I'm going to graph those in green. So that is 2 and negative 4. So at 2 and negative 4. Okay. So now I'm going to find my y-intercept. My y-intercept happens when my x is equal to 0. So I can just do that by substituting it in. I don't have a c value here, so that's why I got to substitute in. So I get y is equal to 2 times 0 minus 2 times 0 plus 4. Simplifying, I get 2 times negative 2 times 4. So I'm going to get negative 16. Okay. And I found my intercepts. B, I want to find the equation of my axis of symmetry. Well, what I'm going to do is I know my x-intercepts are here. So if I want to find, I know my axis of symmetry lies right in the middle. So what's in the middle between 2 and negative 4? That's my midpoint. So 2 plus negative 4 divided by 2. So I get negative 2 divided by 2, which is equal to negative 1. So my axis of symmetry is negative 1, which looks correct on my graph. I got 3 over to the left and 3 over to my right for my intercepts. Okay. So now I have to find my, and I want the equation of that line of symmetry. So this is x equals negative 1, not just the graph of it. Okay. Next part is I want to find my vertex. Okay. So my vertex, I know the x value is equal to negative 1 because that comes from my line of symmetry. Okay, from here. Then to find my y value of that, I just evaluate the function. So I have y is equal to 2 times negative 1 minus 2 times negative 1 plus 4. So I just substituted negative 1 in the value of my vertex into my function, and now I'm going to simplify it. So I get 2 times negative times a negative is positive, so I get positive 2. And I get negative 1 plus 4 is negative 1 plus 4. Oh, sorry, this is addition and subtraction, so I need to be careful here. Minus 1 minus 2 is minus 3. And minus 1 plus 4 is a positive 3. So I'm going to get that this is equal to 2. That's negative 6 times 3 is negative 18 as my y-coordinate of my vertex. So I'm going to be a little off my graph here, but please bear with me. So negative 1, negative 18. Negative 18 is going to be somewhere down here. My graph is extended down. And here is going to be negative 18. Okay. And then notice that my y-intercept, okay, I haven't graphed that yet. My y-intercept was at negative 16. So here somewhere is going to be my y-intercept at negative 16. Okay. And I'm going to have my graph here. Notice that this graph is really skinny because my a value, so my minimum point is there at the vertex, and this comes back up. And there I have my graph of my function. That concludes our notes tonight. Let's make sure you highlight any questions you might have and bring them to class tomorrow.